Hello, welcome to today's lecture on section 6.4, the area between two curves. So we'll see in today's lecture how to compute the area between two curves and how that also relates to the interpretation of a definite integral as a signed area. We have two functions. F is always larger than or equal to g on the interval from a to b. The area between the curves y is f and y is g from x is a to x is b is given by this integral, a definite integral. And it's represented by this region here that is shaded blue. F is the top curve, the red curve, and G is the bottom curve, the blue curve. So let's see what happens. Let's find the area between the curves. Y is minus x squared plus 4x minus 3. That's the top curve, or the red curve. And y is x cubed minus 3x squared minus x plus 3. That is the bottom curve, which is a cubic. Let's set f being minus x squared plus 4x minus 3 and g to be x cubed minus 3x squared plus minus x plus 3. That's the cubic. We compute this definite integral, which is equivalent to, so that there should not have been a minus sign there, negative x cubed plus 2x squared plus 5x minus 6. Its antiderivative of the integrand is minus x to the fourth over 4 plus 2x cubed over 3 plus 5x squared over 2 minus 6x. And when we plug in 3, we get 9/4. When we plug in 1, we get minus 37 over 12. We take their difference ends up being 16/3. And let's look at this. What was the conclusion? What's the conclusion? The area under this curve, this blue region, is 16/3. Now, let's go into the next section. That's about a function that may be negative on an interval. This integral, definite integral, is the sum of the areas between y is equal to f of x, y is equal to the graph of the integrand and the x-axis in regions where the integrand is positive, minus the sum of the areas between y is equal to f of x and the x-axis in regions where the integrand is negative. So here's an example, y is equal to x squared minus 1. And if we look here, well, the definite integral from negative 1 to 2 of x squared minus 1 is the area that's shaded purple. That's where x squared minus 1 lives above the x-axis in the region in the interval from negative 1 to 2. And minus the area of the region that's shaded green. And that is the region in the interval from minus 1 to 1, where y is equal to x squared minus 1 lives below the x-axis. Let's compute an area between a graph and the x-axis. We're going to compute a definite integral from the area of the region shaded green. So notice, if we wanted to compute the area between y is equal to x squared minus 1 and the x-axis from negative 1 to 2, that's the sum of the area shaded green and the area shaded purple. X squared minus 1 lies below the x-axis from negative 1 to 1. The area of the region shaded green is therefore equal to this following definite integral, the negation of integral from negative 1 to 1 of x squared minus 1. The negative sign is present on negative 1 to 1 because the graph of y equal to x squared minus 1 lives below the x-axis. So we can also do a definite integral for the area of the region that is shaded purple. Y equal to x squared minus 1 lies above the x-axis from x equal to 1 to x equal to 2. The area of the region shaded purple is equal to the following definite integral, 1 to 2 x squared minus 1. There's no negative sign because here y equal to x squared minus 1 lies above the x-axis on the interval from 1 to 2. Now we can compute these two definite integrals, these two areas, just by antiderivatives. So that's the power of antiderivatives. They're used to compute areas that could not otherwise be computed. Capital F of x is x cubed over 3 minus x. It's an antiderivative of f of x, which is x squared minus 1. F of 2 is 2 cubed over 3 minus 2. That's 8 over 3 minus 6 over 3, which is 2/3. 1 cubed over 3 minus 1 is 1/3 minus 3/3, which is negative 2/3. Half of negative 1, negative 1 cubed over 3 minus 1/3, that's negative 4/3. You can check over that arithmetic for yourself. The negation of the definite integral from negative 1 to positive 1 of x squared minus 1 dx is the negation of f of 1 minus f of negative 1. The antiderivative of the integrand evaluated at the upper bound minus the antiderivative of the integrand evaluated at the lower bound. Then we take the negation here because it's the area that's shaded green, and that's where y is equal to x squared minus 1 lived below the x-axis. So we get 2, 6 over 3, which is 2. The area of the region shaded purple is 4/3. Add these guys up. 6/3 plus 4/3 is 10/3. The area of the region shaded green plus the area of the region shaded purple is 10/3. Conclusion is that the area under y is equal to x squared from x equal to negative 1 to x equal to 1 is 10 over 3. Okay, so that's it for today's lecture. I will see you all on Monday.